Now we're going to talk about confidence intervals. Suppose you are trying to determine the mean rent of a two-bedroom apartment in your town. You might look in the classified section of the newspaper, write down several rents listed, and then average them together. So you would have obtained a point estimate of the true mean. If you're trying to determine the percentage of times you make a basket when shooting a basketball, you might count the number of shots you make and divide that by the number of shots you attempted. In this case, you would have obtained a point estimate for the true proportion. We use sample data to make generalizations about an unknown population. So this part of statistics is called inferential statistics. The sample data help us to make an estimate of a population parameter. So we realize that the point estimate is most likely not the exact value of the population parameter, but close to it. So after calculating point estimates, we construct interval estimates called confidence intervals. And in this section, we're going to learn to construct and interpret confidence intervals. We'll also learn a new distribution, the student's T, and how it's used with these intervals. So throughout the lessons, it's important to keep in mind that the confidence interval is a random variable and it's a population parameter that is fixed. If you worked in the marketing department of an entertainment company, you might be interested in the mean number of songs a consumer downloaded in a month from iTunes. If so, you could conduct a survey and calculate the sample mean and the sample standard deviation. So we'd use the sample mean to estimate the population mean and the standard deviation to estimate the population standard deviation. So the sample mean, x bar, is the point estimate for the population mean, mu. The sample standard deviation, S, is the point estimate for the population standard deviation, sigma. So each of the sample means, the x bar, and the S, which is a sample standard deviation, is called a statistic. A confidence interval is another type of estimate, but instead of being just one number, it's an interval of numbers. So it provides a range of reasonable values in which we expect the population parameter to fall. So there's no guarantee that a given confidence interval does capture the parameter, but there is a predictable probability of success. So suppose for the iTunes example, we don't know the population mean, but we do know the population standard deviation is 1 and our sample size is 100. So then by using the central limit theorem, the standard deviation for the sample mean is 1 divided by the square root of 100, which is 0.1. The empirical rule, which applies to bell-shaped distributions, says that in approximately 95% of the samples, the sample mean will be within 2 standard deviations of the population mean. So for our iTunes example, 2 standard deviations is going to be 2 times 0.1, which is 0.2. So the sample mean is likely to be within 0.2 units of mu. Because the sample mean is within 0.2 units of mu, which is unknown, then mu is likely to be within 0.2 units of the sample mean in 95% of the samples. So the population mean mu is contained in an interval whose lower number is calculated by taking the sample mean and subtracting the 2 standard deviations. And then the upper number is calculated by taking the sample mean and adding the 2 standard deviations. So you can see here, it's the sample mean minus 0.2, and then it's the sample mean plus 0.2. So the 95% confidence interval is 1.8, between 1.8 and 2.2. So a confidence interval is created for an unknown population parameter like the population mean mu, and the confidence intervals have this form. It's the point estimate minus the margin of error, and then the upper is the point estimate plus the margin of error. So the margin of error depends on the confidence level or percentage of confidence and the standard error of the mean. So when we read newspapers and journals, some reports will use the phrase margin of error, and others will just include a confidence interval as the point estimate plus or minus the margin of error. So these are both ways of expressing the same concept.